Hello guys, am I audible? Please tell in the chat if I'm audible. Okay, so today I'm going to discuss CodeChef Starters 216 Div 2 solutions. I have solved the first four problems. First one is best. So yeah, this is the first question. So in this question, we have been told that Chef and Chefina are trying to watch a cricket game. They have already decided a row of n seats where they will sit, but they have they are yet to figure out the exact two seats that they will buy. And it is said that the cost of the ith seat in the row is AI. So obviously they have to sit next to each other. So they will buy only adjacent seats. And we have been asked to calculate the minimum cost for them to buy two seats so that they are able to sit together. Okay, so what is the logic for this question? Let us try to figure it out. So if I have to find two adjacent seats always, so what I can do is that um, go to every adjacent two seats and take the sum of their costs. So like in this case, I can do what? I can first check the sum of these two seats. It is 198. So if I purchase these two seats, the cost will be 198. If I purchase these two, then the cost will be 105. In these two, the cost will be 99 plus 97, 106. And in this also, it will be 106. So as we can see, the minimum cost was 97 plus 98, which is 195. So what do we have to do in this question? We just have to uh, do AI plus 1 for all the I from 1 to n minus 1. So we basically iterate over all the adjacent pairs and take the minimum possible cost over all of them, right? So solution for this is here is my solution. Yeah, Aditya. Uh, so in div 4, the fourth and fifth problem is what, if you can mention in the chat which were the fourth and fifth problem in div 4, I will reply. Okay, so yeah, this is my solution for the problem. Since we have to find the minimum, we always initiate the answer with a really high value so that when we take the minimum with this value, the starting value has to be kept initially very high. If let us say if I keep the value as 0, then minimum of 0 comma anything will again come out to be 0. We always initialize it with a high value. So once I'm initializing it with a 1 9, I run a loop and go to all the adjacent seats, right? So the cost will be AI plus 1 for all the for two seats, two adjacent seats, right? And I run the loop from 0 to n minus 1. Why n minus 1? Because if I do, let us say if I am here, right? If I am at nth position, then what will happen? 97 plus the next value. The next value does not exist. So it will give me a runtime error. That is why I have to go to n minus 1 only. Yeah, so and this is the solution. You have to take the minimum again and again in the loop, and finally print the answer. Yeah, this is the first problem. It was a brute force solution. Okay, so now discuss the second problem. Yeah, this is the second problem over here. So uh, this is LIS and LDS. So LIS here is the longest increasing subsequence, and LDS here is longest decreasing subsequence. And in this question, they have given strictly increasing and strictly decreasing. Okay, so let me open the whiteboard for this question. So till then, we will read the question carefully. So the question says that, okay, the question says what? So we are basically given a frequency array f of size n. So and an array a of size uh, f1 plus so on up to fn is called good if it contains the integer x exactly f of x times. So I will quickly explain what this means. So it says the size of an array should be f1 to fn. So for example, in this case, the size of the array will be 4, right? So if the size of the array will be 4, let us say the array is currently something like this, 4 spaces, right? And then it is saying that it is called good if it contains integer x exactly fx times for each 1 to n for x, right? So like 1 should occur 2 times. So the constraint is that 1 should occur 2 times. I'm discussing the first test case right now. And then 2 should occur how many times? 1 time. And then 3 should occur 1 time again, right? Okay, so now these are the constraints for this array of 4 size, right? Now what do we have to do? We are given a score, and it is the minimum of LIS and LDS, okay? Where LIS of A is the longest increasing subsequence and LDS is the longest strictly decreasing subsequence. Okay, so the word strictly here means that the next element must be strictly greater than. It should not be greater than or equal to. It should be strictly greater than the previous element. So, right. So, for example, the solution to the first problem has been given as what? 1, 2, 3, and 1. So, longest increasing subsequences in this case is what? LIS here is what? 1, 2, 3, right? And then longest decreasing subsequence here is what? 3 and 1. So what is the minimum of the size of these two? It is this is 3 and this is 2. So the minimum is 2. So the answer they have printed is 2. So this is the array that they have taken as an optimal one for this test case. Now we have to basically the maximum score, and the score is minimum of LIS comma LDS. So we just have to find first of all an array which has the minimum score, or maybe we can calculate the score even without finding the array, right? So as we can see, that uh, in this array 1231 LIS and LDS. I hope you might have understood what are LIS and LDS and what is the score defined in this question. The score is a minimum of the length of LIS and LDS, right? So, um, okay, so what I can do is that uh, I my main focus, if I'm not trying to calculate the array and just trying to solve the problem, should be on the LIS and the LDS. So, uh, I know that um, I will have one LIS and I will also have one LDS, right? So what I can do is that if I am having an element multiple times, since I am having elements from 1 to n only, right? So for example, in this case, I know that 1 is occurring 2 times. So what will I do? I will give 1 and I will give 1 in LDS also. I can do that, right? Because I have it 2 times. Even if I had it 3 times, even if I had it 3 times, uh, m- um, it would be the same case. I can assign it to LIS also, and I can assign it to the LDS also. For example, if I had 1, 2, 3, 1, 1 as the array, right? So I can assign one here and one here. So basically, if my frequency is greater than or equal to 2, I can assign it to both LIS and LDS. But what if my frequency is equals to 2? Now, can I do? If my frequency is equals to 2. Okay, so if my frequency is equals to 2, I can assign it to both sides. And if my frequency is equals to 1, I can assign it only on one side, right? So like in this case, 3 has a frequency of 1. So I can either assign it to this sequence or I can assign it to this sequence, right? So if I assign it here, if I assign 2 here and 3 here, then what will happen? Then both of the LIS and LDS will have two sides right now. But as I can see, the LIS in my case is what? And LIS in my case is what? It is 1 comma 2 comma 3. This means that this means what? That one element has occurred in both of them, right? So like so yeah, sorry, LDS here is 3 1 because okay, so one is assigned to both of them, and 2 is assigned to LIS, and 3 is assigned to LDS in this example. Okay, um, and what we can see here, that 3 is also assigned in both LIS and LDS. And why is that? Because 3 is at a meeting point of the LIS and LDS. Can LIS and LDS meet at multiple points? No, they can only meet on one point. Uh, as in this example, it is clearly visible. So I am defining first count C1, and C1 is the number of elements with frequency equals to 1, and then I will have C2, number of elements with frequency greater than 1. And uh, as I have told you till now, that if the element will have frequency greater than 1, I can assign it to both sides. So LIS size will be C1, C2, and LDS size will be C2, at least C2, because yes, because I have assigned it both sides, right? So this condition should be clear. If this is not clear, you can please tell me in the chat. Um, okay, so yeah, if this is clear, so I have assigned C2 elements both sides because I had a frequency greater than 1. So now I am left with the elements with frequency is equals to 1. So what can I do? I can assign half of the elements this side, half of the elements this side, and another half of the elements this side, right? As I have done in this case, I assigned, so there were two elements that were having a frequency that was not equals to 2. That was equals to 1, right? There were 2 and 3. So I assign 2 to the LIS and 3 to the LDS. Is it right? So yeah, half of the elements this side and half of the elements this side. And as I told you, there will be one meeting point of these two, right? Right. Like in this case, the meeting point was so 1, 2, 3 and 3, 1. So the meeting point was at 3. These subsequences have to meet at one point for the best case, right? So uh, what will happen in that case? Uh, I can assign one more element on either side. Right. So basically, it was not C1 by 2, it was C1 minus 1 by 2. Right. I can assign one element on both sides now. C1 minus 1 by 2 elements on both sides, first of all, and then one element will be assigned to both sides. Right. Do you understand each component? First component is C2. What is C2? The elements with frequency greater than 1. Right. So they can be assigned to both sides easily. That is very true. Then the second component is what? uh, Leave one element of the elements with the frequency is equals to 1. Like in this case, I had 2 and 3. I say let us leave 1, let us leave this 3 and just go with 2, right? So in that case, I am left with C1 minus 1 elements, and now they can either go to LIS or they can go to LDS since they are occurring only one time. So they can either go to one of these. So divided by 2 and plus one element because one element will be in both of them since it is the junction point of these two, right? So the final formula that I will get for this will be the final formula answer will be minimum of these two, right? Because one of them might get the floor of C1 minus 1 by 2, right? So what will be the answer? Answer will be C2 plus C1 minus 1 by 2 floor floor of this thing. Is it clear? It will be floor of this thing. And then plus 1 for the meeting point. What is this one? One is meeting point of LIS and LDS. If you are not clear with any of this, I would give you one more example so that okay, so this is the final formula that we will be having, and it can be further simplified to C2 plus since in the floor. So basically, the thing is that we will do floor of this thing plus this thing. Since this is an integer, it can be directly added inside the floor. So what will you get? C1 plus 1 divided by 2. So this is the final formula. And I will explain these three components with another example as well. So for example, I have the frequency array in the question as 2, 1, 1, and 1 and 2. Okay. So what will be my approach to this question? So I know that I can see I will have LIS and also I will have LDS, right? So what I will do, I can see that 1 is on the LIS side as well, and 5 is also sorry, 1 can be assigned to both LIS and LDS, right? So I assign 1 here and I also assign 1 here. And then again, this 5 can also be assigned both sides, right? So I can assign it in this way. Is that correct? Now I am left with these three. I ke- I decide to keep one of them as a junction. Let us say I keep three as a junction. So 1, 3, and 5 will be on this side, and 5, 3, and 1 will be on this side as well, right? 3 as a junction, this junction element. Like in this case, also it was 3. Is it okay? And then the elements which are left are 2 and 4. One of them will be given to this side because I have decided to give half of them both side, and one of them will be given this side. So this will be the LIS and this will be LDS. And if you are thinking that what will be the final array in this case, the final array will be this. Um, so it is 1, 2, 3, and 5, and 1, 5 here, and then 4, 1. Yeah, so this array will be the final array of this case, right? So it has 1, 2, 3, 5 as a subsequence, and also 5. Uh, sorry. Um, yeah, this will be the decreasing subsequence, right? So 5, 4, 3, 1 as a decreasing subsequence. So this will be the final array. And in this way, you clearly understood all the for the meeting point C1 minus 1 by 2 for the frequency with elements with frequency equals to 1, and C2 for the elements with frequency greater than 1. So finally, we will see the implementation for this question. So here is the implementation. Okay, so yeah, this this is my solution implementation for this question. So yeah, first of all, frequency array, I have taken it as an input, the one based indexing. So f of 1, then f of 2, then so on up to f of n, I have taken as input. If n equals to 1, I simply see out 1, handled an edge case. Uh, why will it always be 1 in case of 1? Um, Let me tell you that also. So for example, if there is only one element, if there is only one element, if there is only one, then whatever is it frequency. So LIS will also be equals to 1, and LDS will also be equals to 1, since I do not have any other element. Like in this case, I had only one. LDS will also be 1 and LIS will also be 1. Therefore, my answer has to be 1. So I handled an edge case. So I simply print 1 for the answer in case n is equals to 1. And so now, since I have to calculate this time the maximum answer, what do I initialize the answer with? 0. Last time we had to calculate minimum, so I initialize it with 1 9. This time we had to calculate maximum, so I initialize it with 0. Um, and then I go to every element. So basically, if its frequency is greater than 1, I do answer plus plus. So this is basically storing C2. This answer is nothing but C2. Okay. Let me actually copy this for you here and tell you what every variable means. So yeah, this as you can see, answer here is what? C2, right? And then uh, and then I have done this final formula. And now how did this final formula come? So I told you that C2 plus C1 by 2, and again we can, since C2 is also an integer, we can combine it to floor of 2C2 plus C1 plus 1 divided by 2, right? And and what can we do here? C2 plus C1 in this case is what? If I actually write it as C2 plus C2, as we know that C2 plus C1 is what? It is equals to the whole array. So basically C2 plus C1 is nothing but n. So n plus C2 plus 1 divided by 2. So this is my final formula that I have used, right? So answer is nothing but C2, and n plus C2 plus 1 by 2 was my answer. So I have finally printed it, correct? So this was the logic for this question. The main thing to notice was this one, that the elements with frequency greater than 1 will be assigned to both of them. One meeting point will also be assigned to both of them. And the leftover elements that are only occurring once will be assigned either to LIS or to LDS. I hope you have understood this question. If there are any doubts, you can write it in the comment section. Okay. Um, so right now I will discuss the next question. So the next question is XOR equals subtract. And then I will also open the whiteboard, since some of you might be struggling to understand it with the comments only. Okay. So yeah, this is the question. XOR equals subtract. Um, it says that an array A is called good if it satisfies the following condition, and the condition is that for all the pairs ij in the array, where I and j are um, in the indexes of the array, ai XOR aj must be is equals to mod of ai minus aj, and uh, this thing right here represents the XOR operator that has been told to us. So you are basically given an array of n integers. You have to find the maximum size of a good subsequence of A. So subsequence is basically, as you know in the last question, just selecting some elements, um, mm, not continuous, but in any way. They might be continuous or they might not be continuous for a subsequence, right? And then we have to do in this question. So we have been asked to find a subsequence uh, that is of maximum size and that is good, and when it is good, when this condition is satisfied. So the condition here is that okay, so the condition is that ai XOR aj. So this operator is also XOR operator. Since this one is not available in the keyboard, I will be using this one. Okay, so ai XOR aj should be equals to absolute difference of ai minus aj, right? This has been told in the question. So if you are not aware about the dynamic programming, you can skip this question because it's based on a dynamic programming approach. Okay. Now also know this property of the XOR operator. If you are not aware of this, that AI XOR AJ is equals to AI or AJ minus AI and AJ. This is the property of XOR operator, and this has to be remembered. So this is important property that you have to remember. Okay, and then okay, so yeah, this is the property that will be used in this question. So that we want that we want that AIs or AJ minus mod AJ, right? Mod minus mod AJ is equals to this thing. Now, we also know that. Let us assume. So yeah, now whiteboard has opened. Okay, let me write in the whiteboard only now. Okay. Let me copy all this. Right. So yeah, these were the formula I wrote till now, and this is what we want. This is wanted, right? And this is a property, and this is just combining these two equations. I substituted ai's or aj with mod ai minus mod a. Now what you can see is that let us assume that assume ai is greater than aj. So what will that mean? That ai minus aj is what is equals to, since the mod will open like this now, right? Mod has to be positive, so ai minus aj is greater than 0, and then ai minus aj equals to ai minus aj equals to this thing, ai or AJ minus AI and AJ. So you have to be aware about the properties of bitwise operators for this question. If you are not aware about these properties, you can study it from GFG or any resource if you want. For this, you can ask me in the chat also. And yeah, this is more or less it. So for AI or AJ minus AI and AJ, we can what we can do now is that let us write it as AI, right? Write it as AI and write the other thing as AJ. Yes, this is the thing that we want in reality, right? So we basically want that AI or AJ is equals to AI. What is AI? The maximum of the two. And AI and AJ is equals to AJ, right? As you can see this on comparing these two sides, right? So now what is the idea that we have to use? So in the question, we have to find the maximum size of a good subsequence of A. So I have to go on a subsequence of A and this condition must be obeyed. So basically, what I want first of all now what is wanted? First condition is that AI or AJ is equals to AI or basically the max of AI comma AJ and AI and AJ is equals to min of AI comma AJ. This is what I want, right? This is what I want. And how will I actually satisfy this condition? So let us first of all, kind of try to do it for this test case. So the test case number 4 I have taken, which was 1, 3, 11, 11, and 15. I've sorted this array because we have to deal with maximum minima. So I've sorted this array currently. And obviously we have to find subsequence so the order does not matter since we have to just select elements, right? So for what will I see here? Let us write all of them in binary first of all. So if I write, and also um, if you are aware about the bitwise properties together, like if AI and AJ is equals to minimum of AI comma AJ, then basically the AI or AJ will be equals to the maximum of